Hi, good afternoon, everyone. I'm Mark Hasler, Business Development Manager for AutoStore. I'm also the Vice Chair for the ASRS product group inside of MHI. So thanks for joining us for this seminar on determining what ASRS solution is the best fit for my application. Joined by two other presenters on here today. Let them introduce themselves.
My name is grant.beringer. I work for Swisslog Logistics. I head up our West Coast office in California.
Hey, I'm Matt.Rivenbark, and I'm Executive Sales Manager at Schaefer.
So before we jump into the presentation, I wanted to show you a quick listing of the active members of the ASRS product group in MHI. We're going to be diving into a lot of the technologies for these equipment manufacturers today. Obviously, we're not going to cover every single type of ASRS solution out in the market, but if you have any questions or want more information on these equipment suppliers, hop on mhi.org. You can find out more there. And likewise, if you're an end user or a component supplier, and you think you want to be a part of MHI or in particular the ASRS product group, come up to myself, Matt, or Grant after the presentation, and be happy to talk with you more about it. So I'm going to hand it off to Matt now, who's going to talk to you a little bit more about some of the data requirements, project requirements, things you should be considering when moving towards an ASRS solution. Matt?
You got the mover? Is this thing working too? Can you hear me? All right, cool. I don't know if you want to hold on to that. So I'm going to walk you through a little bit about what kind of requirements you need to think about before you start getting engaged and figuring out what kind of ASRS you want, or starting to work with different vendors to look at solutions. All right, so you want to build an ASRS. So there's just a general list of questions up there. What are my load units? What are my throughput requirements? What's my order structure? Different storage requirements? How many SKUs am I storing? What's my building situation? And obviously you always want to plan for the future with this type of thing. So I'm going to drill down into these different areas as I go through the presentation. So as my engineering director always said, in the beginning there was a load unit, and obviously this is the big key component you want to get a grip on as the ASRS that you're going to have is to be designed around what that load unit or transport unit is. How are my items received? Are they coming in full pallets? Are they coming in rainbow pallets? Are they going to be mixed SKU pallets? How are they picked? Are you picking, full pallets? Am I picking layers? Am I picking cases, or am I picking eaches? How are they shipped? Are they going out in full pallets? Are they going out on mixed pallets? These are all just things you think about when you try to define what an ASRS system, what you're storing and what your material flow looks like. So what items do I have? Is there any kind of characteristics about those items that might make them stored in different locations than others? Is there ambient storage? Is there cold storage? Do you have any kind of caustics or other types of materials that can't be stored with other certain types? Are they large items? Are they small items? Are my products going to be conveyable or totable? And if you're not familiar with what totable is, that's basically automation lingo for does it fit into a tote? Obviously, the biggest thing is, what is your data you're looking at? I mean, when we start discussions with clients, we send out our request for data. Customer always starts to get a little bit of anxiety as they figure out what they have and what they don't have that we're asking for. But once you send that information over to your vendor, they're going to take a look at very detailed at the specific order structure of those items. So when I think of key data, I think of the following things. So number of orders per day, number of order lines per day, how many picks per day, how many picks per order line. I mean, I don't know if everybody's familiar with all these different terms, but this is what your automation vendor is going to look at when he tries to define, what the throughput requirements are for your system and how they design that. So, how many SKUs you're storing in your building, how many of those are active per day, how much inventory do you have for those items, how many storage locations do you currently have, or are you thinking you're going to need for your future ASRS build? What's your SKU profile? What's your ABC curve? Typically 80-20 is going to be your gold standard. So 20% of your items are doing 80% of your business. But it's just something to think about, as you start to gather data and things to send over to your automation vendors. The next big topic, where do I put this thing in my building? You know, do I have room in my existing building? Am I looking at expanding my building, or am I looking at building a new one altogether? You know, what's the clear height of that area? Because obviously, you know, the technology that we're using, it's heavily dependent on how much space I have or what the throughput, what the clear height requirements are. It really helps me to understand what I can build and where I can build it. And even if you're going to build a new building, I'm going to say this for the people in the back. Make sure you're talking to an automation vendor before you finalize your building, because there's nothing worse than getting handed a footprint of a building and you say, well, what can you put in here? You know, because it may not match what I want to do, and say, well, you know, can I go taller? Can I go wider? You know, can I change the material flow? These are important things. So make sure that you're definitely talking to an automation vendor before you finalize that building, because I guarantee they're going to want to have some input there. You know, and that goes into the next slide. You know, how do I plan for the future? You know, you don't want to put this ASRS somewhere where it's in a room, or it's off to the side, or if it's somewhere that you don't have any kind of, you know, expandability built into it. So, you know, you don't want to landlock it. You want to put it either in an area where you're going to be able to build further in one way or the other, or obviously against a wall where you have more land that you can possibly buy or develop to do an expansion later. Because, I mean, typically clients we work with ask for a 5-year and a 10-year plan. So 5 years your base installation, and 10 years, you know, where do I go from there? So it's always important to think about when you're putting these things, how your future expansion is going to be taken into account. Just some other good things to consider. You know, how far in advance do I get my orders before I pick them? That's very important for throughput, and you know, a lot more detailed things that go into development of the system. When does my peak take place? Obviously, a lot of people have the Black Friday peak. Other people's peaks coincide with their specific businesses. You know, when am I seeing that? How do I attack it? How do I build the system to incorporate it? What is my current shift structure? Just because you're working, you know, one shift today doesn't mean you want to work 3 shifts in the future, because, you know, an automated system is a fixed cost, right? And if I can spread that out, that throughput requirement over multiple shifts, I can lower my investment costs. You know, there's a lot of things to think about from that. What's my timeline? You know, you always get into these discussions and customers like, well, I need to be live in 6 months. And you just, you know, kind of look at them and shake your head a bit and think about, guys, that's a little too fast, number one. I mean, typically, you know, I don't know what you guys' opinion is, but typically, you know, an implementation of an ASRS is going to take somewhere between, I don't know, a year to 18 months, depending upon the size. So just something to think about, that you're starting this process early enough to coincide with your goals. You know, what sort of ASRS technology best fits my application? And I think these guys will talk you through a little bit about some of the technologies we've highlighted, so you'll get a better idea just by leaving this room, you know, where I think my automation journey might start. And obviously, you know, IT is very important here. Think about your current IT situation. You know, we don't want to recreate the wheel here. If you're happy with stuff your WMS already does, you know, we just want to fill those gaps. But at the end of the day, you know, most of these companies are able to do anything to a full WMS. So if you're building a new building, you can start from scratch right there with your automation vendor. I think that's it. You're up, Grant.
Thanks, Matt. So Matt's given you there a bit of an idea of some of the requirements in terms of starting your design and what you should be thinking about. What I'm going to do next is give you a high-level summary of some of the ASRS solutions that are available, so you can start to think which is most suitable for me. Obviously, there's some detailed work to be done to understand your specific requirements, but this might give you an idea of the sort of technologies that are out there that you might be led towards. So for each of the technologies, I'm going to ask the questions: how does it work? What are the typical uses? And we'll look at some of the typical performance metrics for each. So the first one that you can see there is the traditional SRM, or storage and retrieval machine. So how does it work? Essentially, you've got a crane operating in a single aisle, so one crane per aisle, with a fork which moves up and down the mast. The depth of storage in the rack is typically 1, 2, or 3 pallets deep. And typical uses of full pallet storage, so you might do full pallet dispatch. It might be a pallet storage which then feeds a case buffer. It may then also be used to replenish pick slots. So you can see there the performance metrics, relatively speaking, compared to other ASRS technologies. The throughput, we would say, is medium. So about 20 to 30 pallets per hour per aisle is typical for an SRM. In terms of storage density, again, relatively speaking, it's medium. You've got essentially 1, 2 or 3 pallets deep per aisle. And then that means you've got a large number of facings, so typically used for a high number of SKUs. If you have a large SKU range, this is usually the most suitable application. Relative cost, again, is medium. So, again, sticking with pallet technologies, we take the same SRM, in this case, and add a satellite rather than a fork unit. What we're getting at this point is the chance to store multi-deep in the rack. So at this point, the storage depth is unlimited. It's really based on your particular SKU profile. Again, typical uses, it's pallet storage, large pallet buffer. Throughput in this case is still medium, if anything slightly lower, because you've got longer depth or deeper storage of pallets, but you're getting a higher storage density. For every aisle, you can have 10, 20 pallets deep, so you're getting very high storage density, which means it's typically used for a medium number of SKUs. Relative cost is slightly higher now because you've basically got channels which in the rack rather than top hats or beams, so the rack costs are slightly higher than your traditional SRM. Next one in the line, still staying with pallet technologies. This is a Pellet Shuttle. There it goes. So how does it work? In this case, rather than having a single crane per aisle, we have vehicles on individual levels, each one bringing pallets up and down the aisle. And then on board that aisle carrier is another vehicle called a row carrier, which is then depositing the pallets into the row. So in this case, the throughput steps up a bit. We get much higher throughput because each level has essentially got its own vehicle operating at 20 or 30 pallets per level. The throughput is going to be restricted at that point by the vertical lift, which is bringing the pallets at the front of the aisle in and out. So again, here we're getting very high storage density and very high throughputs. And for that reason, because you've got higher storage density, it's typically used for a lower number of SKUs. So large batch sizes, but with a lower number of SKUs. Again, the relative cost is slightly higher just because of that rack, which is requiring channels and slightly higher tolerances than a typical SRM. So moving now to a case or tote-based ASRS solution. First one is Miniload. You can think of this one as the equivalent of a pallet SRM, but for totes or cases. So how does it work? You've got a single crane per aisle, again depositing totes or cases, either 1, 2 or 3 cases deep into the rack. For that reason, it's typically medium storage density. For a high number of SKUs, you've got a large number of pick faces or rack faces. Relatively speaking, it's a medium cost level. Again, moving along towards a shuttle solution, so you can think of this one as the equivalent of the Pellet Shuttle, but for cases and totes. We're stepping up the throughput at this point. Each level has its own carrier depositing cases or totes. So at this point, we're looking at about 400 or 500 cases per hour. Storage density is about the same. You're not getting that multi-deep storage. Essentially, you're getting the depth that the carrier can reach into the rack. The cost is slightly higher than the Miniload. You've got more equipment, and again, the rack is slightly more complex. Now, Mark's going to tell you a bit about different cube storage applications.
I got this one. Oh, appreciate it. Yeah, so I happen to know a thing or two about this one. Cube storage is comprised of bins that are stacked one on top of another, and basically a denser Rubik's Cube of storage. So you're eliminating the need for aisles. You're eliminating the dead space you would see with typical shelving. Robots run on top of the grid, which is basically supported by this aluminum framework. And those robots will run to dig up a bin, retrieve a bin, and bring it to a workstation that is attached where the operator will fulfill an order or also use it for replenishment and put away. So throughput is on the medium-high level. It's really dependent on the number of bots that you have on the system. So the more bots you have, of course, the more throughput you're going to get. The more workstations you have attached to a system, the more rate you're going to get. A cube storage can be as small as something that is 1,000 square feet. It can be as large as 100,000 square feet. It can be 1,000 bins. It can be 300, 500,000 bins in storage. So it's pretty flexible in terms of number of bin locations. Storage density, it's high. It's the highest you're going to see probably for light goods, each picking ASRS solutions out there. Number of SKUs is high. You can see the number of bins. As I mentioned, you can have 300,000-400,000 bins in a system, or even up to 1 million bins. Those bins can be slotted to accommodate partitions and dividers, so now you can have multiple compartments or multiple SKUs in a single bin. Relative cost is medium high. Cost drivers on that are really the number of bots. So you could be industrial components, or let's just say you're in aerospace, and you're an airline, and you have a lot of widgets, but you don't really need the high throughput. But when you have an aircraft on ground that needs that widget, you got to have it now. And so maybe they might have a high number of bins, but a relatively low number of robots on that system. So the cost might not be as expensive as you would think. Likewise, you might have a smaller system that is an e-com application that requires really high throughput. Now you have a high number of robots. So it's really all dependent, but mostly for case and split case picking. Horizontal and vertical carousels, we lump these together, but they're kind of two different animals. So I'm gonna cover them separately. Let's cover horizontals first. So usually implemented in a pod, you'll have 2 or 3, even up to 4 horizontals that an operator is standing in front of. 3 horizontals will be spinning, presenting that next pick face of shelves that are essentially traveling on an oval track, and presenting that next pick face to the operator. Some advantages with horizontals, they can be used in higher speed, order fulfillment operations. They're also good for lower ceiling height facilities. So if you have 18-foot clear, maybe a horizontal carousel is a good fit. Technology that's been around for a while and very proven. So I would say they're probably more in the medium throughput range, horizontals. Storage density, it's relatively medium. You can get some different types of bin or shelf widths and also depths, so there is some flexibility there. If you're putting different, maybe you're putting totes in there that are holding nuts and bolts, or you have more different size cases. So it's pretty flexible. Number of SKUs, low to medium. It's not a super dense system, and cost is on the lower side. So let's do horizontal verticals now. It's going to be the smallest footprint solution you're going to see here today. Horizontal, it's chain driven, and it's presenting fixed shelf positions to an operator. So you'll see them in a tool crib application. Maybe it's a point of use device for like a manufacturing cell. Big in centralized hospital applications. I'm trying to think what else. But yeah, because the off the wall depth is going to be really small, because you don't have that center flue like you'll see in a VLM application, and it presents a front pick for the operator instead of something that's more of a true overhead pick. So the width of those shelf presentations can vary depending on the type of vertical carousel that you're dealing with, and also the weights of the bin can vary as well. So they can hold some pretty heavy inventory, long goods, motors, whatever it might be, it could potentially hold. And generally for lower height applications than what you would see from like a vertical lift module. Vertical lift modules can go 40 foot clear, or higher, 45. Vertical carousel, you're usually not going much over 24 feet or something like that. I haven't seen too many because there's a lot of moving componentry there, and they do have to be somewhat load balanced, meaning the front end has to be similarly balanced to the back end. We're flying through this presentation, so I hope you guys got a lot of questions. Vertical lift modules, VLMs, vertical point-of-use device. They can be implemented in banks of VLMs to help increase throughput. A little bit more flexible in regards to the height of products that you put in. What's cool about a VLM is you can throw in an 18-inch tall part, and it'll store it dynamically in an 18-inch tall location. So it's a little bit more dynamic in how it stores the trays that get put back in. It can hold some heavy product, long goods. It's not uncommon to see, really long, heavy products in VLMs. You could have a manual hoist over the top of one of those trays to pick out something really, really heavy, a couple 1,000-pound motor or whatever, or die. But it can also be flexible. It has those partitions and dividers to hold small nuts and bolts. Very common for that. So your throughput is going to be low to medium with VLMs. You might see 60 to 120 tray presentations in an hour if you were really trying to cook. Storage density is a little higher than what you'll see in a horizontal or vertical carousel. Number of SKUs, low to medium. I'd say an average height VLM, if you're storing nuts and bolts and things like that, you might see 1,000 to 4,000 SKUs stored in a single VLM. And the relative cost is low to medium. That entry level cost for single VLM, can be under $100,000. Likewise, they can get, really big ones can get up to, well over that. So, split case and case picking applications for both. That pretty much covers it. Do we have something? Yeah, so we'll open it up for questions now. Talk to any of these technologies, so feel free to fire away. Any questions? You guys got to have some questions. Come on. What's the max height of you mean cube storage automation? So we can go, cube storage automation can go up to 6 meters high to the top of the rails that the robots ride on. And then at least AutoStore for our application requires about another 2 meters on top of that. So you're looking at, 27 feet to the tippy top of the system. And then you're going to want some standoff for your sprinklers, of course. So if you got a 30-foot clear system or 30-foot clear height facility, it can be an ideal fit. But it can be tailored to go shorter if you want to lower the height. Yeah. Correct. Yeah, 12 to 18-month implementation. Do you want to answer that, or? Yeah.
Yeah, I think he was talking for a large pallet ASRS solution. Typically installation for the rack around 6 months, commissioning about 3 months, and startup 3 months. I mean, rule of thumb, 12 months, I would say, from start on. So looking at the construction phase, probably 18 months, but on site for the ASRS installations, typically 12 months from start on site to go live.
Yeah, so we looked at some other solutions too, like VLMs. You can throw in a VLM real quick. So yeah, a horizontal can go in real quick. Cube storage, I would say 9 to 12 months is very realistic. Yeah. Yeah, what is the time frame for the profiling to figure out exactly what solution you want?
Yeah, I mean, I would say the typical sales cycle is probably about a year, and that's, with breaks and things, obviously clients are usually busy doing other stuff, so they're not automation full-time, right? But, typically I would say somewhere from 6 months to a year, from first contact until contract award, and then you're looking at 12 to 16 or 18 months for the installation part after that.
Yeah, I'd only add, it can depend a bit about how well you know the requirements. A lot of that, gathering of information, and then also predicting the future to make sure you've, built the system to accommodate your growth. So, yeah.
Any other questions? You said what's a typical payback ROI period, right? It depends on how good you are currently. If you're very bad right now what you're doing, there's a lot of room for improve, and automation's a big jump. You could pay off within 3 years probably. I would say typical is 3 to 5, and in some cases where you're semi-automated already going to full automation, it could even be a 7-year payback period.
The other thing I would add to that is, are you, how much labor do you currently have? Obviously labor is a huge factor. Are you saving a ton of labor? Or are you bursting at the seams right now in your facility and you're having to consider, blowing out your facility and doing a big expansion? What's that going to cost you? Or are you considering having to move your existing facility to a different area because you're crammed? Can you put in an ASRS solution, gain back 75% of your space, stay in that facility for another 5 to 10 years? Now ROI starts to look really attractive, really fast. Under a year sometimes it happens. So it's really dependent upon your application when it comes down to it. It's a lot where these these integrators can come in and do a deeper dive into your operation and let you know kind of where some of those paybacks are going to come from. Yeah. Yeah, unexpected challenges. I'm sure we probably all have something to say there. Sometimes people are surprised by floor flatness with some of these big ASRS systems. You need a really flat floor. You might have to lay a self-leveling epoxy. You might have to lay a new slab. So it's things to consider there for sure. What else you guys got? I know you got a few more.
I think it can be easy to, underestimate the level of coordination to put an ASRS system together. There's a lot of different subsystems and therefore subcontractors that need to be managed within a tight space. Everything from the rack installer to the fire protection, and it's quite a sequenced course of events which needs to be carefully coordinated. That's for the installation, and then you also have obviously the software and the control level coordination that needs to happen as well. So I think it can be underestimated the level of complexity to put an ASRS, at least the large pallet ASRS solutions together.
Go ahead. I would say reference FEM.
Yeah, the question was what is super flat when we're talking about the concrete flatness. So,
I think some people get hung up on how flat it has to be. Obviously flat is great, but there's ways you can go about it with shimming and stuff that takes that out of account. More, it's the deformation of the slab, as long as it follows the FEM standards for that. If you guys aren't familiar with FEM, we're a German company. It's a European regulation for basically governing of ASRS, and a lot of people in America don't know what it is, but it's still what we use as a guideline for all the stuff ASRS basically. So it's going to be able to tell you what kind of deformation and stuff is acceptable for ASRS.
But if you're installing a large, pallet ASRS or Miniload ASRS, you would have to spec the slab to suit. And I mean, there are workarounds that you can shim if you haven't got the flatness you required. What are the temperature ranges? Yeah. For Miniload in particular? Yeah.
I mean, I would say freezers, our equipment's rated for -20, which I think is you typically see for the coldest that you get with ice cream and things of that nature. I mean, there's certain applications where you go even deeper down that rabbit hole, like blood plasma or something that could be -40, but I think typically you're somewhere between -10 and -20 for most freezer projects. Is that the question? Our case shuttle is rated to -20 as well, so it could be handled for case picking within a freezer. Do you know which one he's talking about?
You mean you mentioned 3D, the footprint. So per aisle, you're going to have, for the aisle, 1 pallet. Yeah, so 4 times the pallet width, essentially, right? With plus some clearance, yeah? So, you could roughly do, 100 mil clearance between pallets each, and times 4. Correct. That's correct. Yep. So yeah, that would be a triple deep fork, and then as I said, there's the opportunity to have a shuttle on board the SRM if you wanted to go deeper than that. Yeah, at least we have a crane that does 3 pallets deep. Yeah. Okay.
Any other questions?
Last round, last chance. All right. Thank you very much.